welcome to Tuesday's edition of Cracking the Cryptic. It is Tuesday today, isn't it? I'm actually going crazy. I've forgotten what day it is. It is Tuesday. Not a good start to a video, especially a video in which I'm going to be attempting a puzzle that has absolutely decimated our testers. This is called 2D Wave Particles by Zetamath, and I believe that this is some sort of tribute to a puzzle by the great Totally Normal Cat, a constructor I view in the very, very highest regard, who somewhat disappeared from the setting scene recently. But I hope, Totally Normal Cat, if you're watching this, you're going to be back with us soon. Now, yeah, this is, I mean, it obviously looks very beautiful, this puzzle, but I've just been basically told, allow yourself a very long time and be prepared to fail. So that's that's not very encouraging, is it? But I do hope that I'm actually speaking to you now and you are watching this video, because that will mean that I've actually got through the puzzle, and that will be a source of some pride. So I'll read you the rules in just a second. Anything to mention beforehand? Just that we are creeping up slowly but surely towards 400,000 subscribers. If you do enjoy the channel, please do tick the subscribe button. We'd be most grateful. And if we do get to 400,000, we're going to make a video where we answer community questions. We've already had loads of questions in. So if you'd like to submit a question to us, just email us at crackingthecryptic@gmail.com or tweet at us at @crypticcracking. And then your questions will also be answered. Anything else to say? Sorry to interrupt myself, but I forgot to mention two things that I need to tell you about. The first is that tomorrow, 10 AM on the channel, we're going to be releasing a very special video. There was a crossword competition held in the USA at the weekend called Lollapuzzoola. And we had a recommendation to try one of the puzzles from that tournament because it was an absolute worldie, apparently. And Mark has had a go at that, and he's going to release the video of that 10 AM tomorrow. So check it out. You won't regret it. And you can even play the puzzle too. And then the other thing I wanted to mention, which I somehow forgot, is that Zetamath, of course, we've just released a bonus on Patreon. A bonus sort of 6x6 conglomeration of Zetamath's puzzles, which has been garnering incredible reviews. So if you are a patron of the channel, get yourselves over to Patreon once you finish this one, of course, and have a go at that. Right, sorry, back to myself. I don't think there's much else to mention, to be honest. The Witness, the next time I'm going to try and live stream this wonderful game I've been playing recently, will be Thursday night. That's currently the intention. So, all that said and done, let's get on with 2D Wave Particles. And I'll read you the rules. We've got normal Sudoku rules apply. No two cells in the same position within a box can contain the same digits. Right, so this is disjoint sets, which is absolutely horrific for me because it requires just superhuman scanning to be good at. What does it mean? Well, let's look at a box of the Sudoku. And each position in the box is sort of, you know, this is the top left cell, this is the top middle cell, this is the top right cell, etc. And basically, let's imagine that square's a 1. Now what we cannot do is put a 1 in any other top left position of a box of the Sudoku. So none of those cells could be the digit 1. And then another way of thinking about this rule is to basically highlight all of the top left cells of boxes and say they have to be a complete set of the digits 1 to 9. The same would be true, obviously, of the bottom right-hand boxes. They've got to be a complete set of the digits 1 to 9 as well. So every box position, if you like, has to be a unique number. And why do I find this difficult? Well, of course, what this means is normally I have trouble enough scanning the row, the column, and the box. So the implications of this 1 would normally be confined to sort of these cells. But in this puzzle, I also have to scan those 4 squares, which is incredibly difficult for me to do. So don't blame me if this all goes wrong. Oh, Maverick's taken off. What a surprise. Just about to fly past my window. Right, let's carry on with the rules. The cells separated by the black dot have a ratio of 2 to 1. That's this, presumably. So that means that could be a 4, that could be an 8, for example. These are in the ratio of 2 to 1 because 8 is double 4. It could be a 2 and a 4, or it could be a 4 and a 2, or it could be a 2 and a 1, or it could be a 3 and a 6, etc. So this is limited, but I suspect this is not going to be the crucial part of this puzzle. I suspect we're getting onto the crucial part in the next part of the rules. Digits on a purple line must be between the digits in the circled digits, between the digits in the circled cells, I think that should read. I'll change that if I get through the puzzle later. Digits on a purple line must be between the digits in the circled, between the digits in the circle. I think it should just say in the between the circled digits at the end. That would make more sense. So, what does this mean? Maybe this is why it's decimated the testers. They didn't understand the rules. I don't think so. Basically, what that means is, let's look at a purple line. Let's fill this line with, I don't know, 3 and 5. Now we know the circles bounding this 3 and 5 must contain digits that are either side of 3 and 5. So we could have a 1 there and an 8 there. That would be absolutely fine because 3 and 5 lie between 1 and 8. We could have, the minimum we could have would be 2 and 6. Because obviously if we go any closer, if we try and do 3 or something, or if we go 4 and 6, 3 and 5 do not lie between 4 and 6. 5 does, but 3 doesn't, so don't do that. Now what else have we got? We've got the upper right vertical line is an arrow. There is no denying that, is there? The digit in that circle is the sum of the digits along the arrow. Right, so this circle is doing double duty, I think, because it does have, look, a purple line extending towards it. I think the reason it's been left unshaded is to sort of highlight the fact that actually this line here is not a between line, it's an arrow line. So this circle has to both... Let's just try and fill this in somehow so that we can understand how it works. Let's put 1, 2 and 3 on the arrow. This would be a 6. Now this, then, that could be a 9, 8, sorry, I meant to put 8 in there. So something like that, I think, is a valid way of filling this little part of the grid. Because now, in terms of the between line, 7 and 8 lie between 6 and 9. And in terms of the arrow, 1, 2 and 3 add up to 6, and then this 3 would act as the between line boundary for this and this. This is completely absurd. Right, so I think I've got through the rules, not without comment, but I have got through them. Do have a go at the puzzle. Allow yourself some time, I'm gathering. Now I'll have a go. My turn. Let's get cracking. And, well, I want to start here, to be honest, because I do at least know that this is a high digit, because this is a 3-cell arrow, and all 3 cells on the arrow are in the same column of the grid, so they've all got to be different digits. So that means that these squares at a minimum would be 1, 2 and 3, and that means this square at a minimum is a 6, so it's got to be 6, 7, 8 or 9. And then it's going to act as a boundary for this between line. And that is already irritating, actually. I was thinking what was going to happen because of this sort of lattice shape is that we were going to get some sort of high-low parity developing. So if we knew this was a high digit, we'd know this was a slightly lower digit, etc. But actually, in fact, this is the example I just did. If we did a 6 there and a 9 there, this can go upwards. So although this digit here looks like it has to be a relatively high digit, there's nothing preventing that from being an even higher digit, which is very annoying and suggests that this is not the break-in that we're going to be looking for here. I don't think that this arrow is terribly helpful. So I guess what we've got to do is to think about, I was going to say 1s and 9s, but now I'm not actually sure even that's correct. But all I'm thinking there is that 1 and 9 is the only digit that can't appear on the between line, because obviously if you try and put a 1 on a between line, you have to put a 0 to bound it. You can't put 0 in a Sudoku, and similarly you can't put 9 on a between line, because 10 is not a valid entry either. So all of these cells here, I don't know what colour should we make those, Is that, ooh, I don't really like that. I'm going to make them blue. Yeah, I can see the purple fairly clearly. So all of these cells can't be 1s and 9s. And I was thinking that might do something. I was worried about this domino though, because this domino, well, this domino can't have a 9, which makes me think the 9 is more restricted. So from a 9 perspective, we could do that. But from a 1's perspective, we could absolutely have a 1 on an arrow. Oh, right, yeah, hang on, I was forgetting one of the rules. Which is the disjoint rule. Right, so actually I can only put 1 9 in all of these cells because they are all the central cells of their box. I can only put 1 9. Right. This is horrific already. This is horrifically difficult. Because I think there is a restriction on 9s for sure, but I don't know to which row the 9 is restricted. Let me explain what I mean. In fact, we might be fine with 1s as well, because this is only affecting the columns. Whoa. Right, let me explain what I mean. Let me just lump a 9 into the grid. I'm going to lump a 9 in here. And now, the moment we pick one of these 9 cells to be a 9, and we will surely have to do that because these, remember, are a disjoint set of the digits 1 to 9. The central cells in each box must all be different because of the disjoint rule. So once we pick this as a 9, we're then faced with a quandary. Look at row 5 and row 9 now. And where do we put the 9 in these rows? And the answer is only, in row 5, there's only 2 cells left, those 2. And in row 8, there's only 2 cells left, those 2. So we would have to stuff the 9s into exactly one of those 2 cells, and then exactly one of these 2 cells, which is forming a rather cute X-wing straight off the bat, because the 9s will either be in those 2 cells, or these 2 cells. Now, what I've noticed as well is that our ability, I should say, to put a 1 on this arrow doesn't affect the exact same restriction happening to 1s. So can you have a 1-9 X-wing? That's the question I'm asking now. Wouldn't be a deadly pattern because of course these are in 4 different boxes of the Sudoku, so it would be possible to differentiate what would otherwise be a deadly pattern, a uniqueness problem. You know, if you had a 9 there, for example, that would resolve the whole pattern. So I'm wondering about whether you've got a problem with the Wow, right, yeah, okay, I have deduced something tiny, but I'm going to tell you what it is. You can't do this. So what you can't have, it appears, is something like that. And the reason you can't have that, you can't have the 1 and the 9 in the same row of the lattice. When I say the lattice, I mean the circles. You can't have the 1 and the 9 in the same row of circles. And that's because if you now look at what that creates, so you can see in row 5 now, the only places for 1s and 9s are these 2 cells, and the only places for 1s and 9s in row 8 are these 2 cells. And at first blush, this looks okay, but I think you've now got a problem with 2s and 8s in the circles, because, oh, that's Mark calling me. Not a good time, Mark. Because now, where do I put 2 in this row? And the answer is I can't put 2 on the between lines anymore because I can't put 1 around the outside of it. If I put 2 on this between line, I need a 1 in one of those two, and I can't put 1 in. So you've got to put 2 and 8 in 2 of these 3 squares. But now I've taken the 2s and 8s out of the circles. So in this row, I've got a terminal problem, because I can't put 2 on the blue lines, because then I'll need to put 1 in a circle, and I can't put 2 in a circle because I've already used my 2 in a circle in row 5. And the same logic is true for 8s. We could have just replaced 2 with the word 8 in the last 5 minutes of diatribe, and we would have reached the same conclusion. So this is already quite interesting, isn't it? What we can't do is put 1 and 9 in the same rows. So what does that mean? Let's move 1 downwards a bit and just try and identify whether that means anything sensible. So now I shift the problem, don't I? Well, okay, so now I've created a new X-wing for myself. So the moment that the 1s and 9s are not in the same row, which they're not, you can see that if we now look at row 2 of the grid and ask where 1 goes, 1's moved to the perimeter cells. And we do the same in row 8, 1 is in the perimeter cells. So we do end up, well, however we arrange the 1s and 9s, because, this is so difficult. But remember, the 9 doesn't have to be here. The 1 doesn't have to be here. So these rows are all fluid. We could be flipping them. We don't know where the 1s and 9s live. But because we know for sure that the 1s and 9s aren't in the same row, we do know that in one row, we don't know which row, but we know it's row 2, 5 or 8. We know in one row we will form a red-yellow pair, aka a 1-9 pair. And it's either, as I say, we don't know where this is, so we've got to be very careful with extrapolating whatever this means. Basically, we can only use this to tell us something about the row, because we don't know whether this 1-9 pair that I've drawn in here is occurring here and here, or here and here. We just know it must occur in one of those 3 rows. Now, if you get a 1-9 pair, presumably, in that row you do get the 2 and the 8, because you've still got the problem of where do you put the 2 in the row. You can't put it on the between line, so it's going to have to be in a circle. And the same is true of 8. You can't put 8 on the between line. So we've now learnt in this puzzle there is one row that does that. It has 2 of its 3 circles filled with 2s and 8s. Which of course means I can't now use 2s and 8s in any of the other circles. Can't use 2s and 8s in any of the other circles. So what I can't do oh, good grief. Right, okay, this is already crazy clever. Right, okay. Yeah, I don't think that I've lost generality by stating what I'm about to state. Now, look at this row. So we know that there will be a row in this puzzle, and it's either row 2, 5 or 8, which has a 9 in it, which does not have a 1 in it. Now, in that row, we have to deal with the digit 8. We've got to put it somewhere, and we can't put it on the between line because we can't put 9 in the circle. So we're going to have to put 8 either in a circle, which we can't do because the 8 in the circle is consumed by the one, the row that has the 1 and the 9 in the perimeter, not the row that has the 9 but not the 1 in the perimeter. So this row has to have an 8 in the perimeter. And now in this row, do we know? Yeah, okay. This is really clever. Right, okay, so in this row, now the problem digit has become 7, because the 7 can't hide on a between line because the 8 and the 9 aren't available to bound it. So that in this row, there is a 7 in one of those two squares. Well, although, when I say in this row, I mean that there is a row in the puzzle, which is either this one, or this one, which does have 8, 9 on the boundary and does have 1, 7 in 2 of its 3 circles. But we don't know that the 1 is here. The 1 could be anywhere, apart from there, I suppose. That is not the 1. So now I've used 7, I've used 2 and 8. Not in this row, which is bounded by a 1 because 1 is yellow. So in this row, the problem digit is 2, presumably, because I can't now put 2. Oh, this is so beautiful. Right, yes. So, in the row that is bounded by 1, but not 9, we have to ask where 2 goes. And the answer is, well, the answer is it can't go on the between line because you can't put 1 in a circle. And it can't go in a circle because 2 has been already used in the row that has the 1, 9 on the perimeter. So the 2 goes in the sides of this row, which makes 3 the problem digit, because 3 now can't hide on the line because you can't put 1, 2 in the circle. So 3 has to go in a circle in one of these, and I'm absolutely putting the 3 into this square, because although if this was the sort of disposition of the digits, this could not be a 3, because we can flip the rows round. It's absolutely possible that the 3, well, the 3 could be here. I mean, the 3 could be anywhere. It could be anywhere. Literally, it could be anywhere apart from that square. So I mustn't lose sight of the fact that 3 is, well, in the rows that have 1 and 2 in the perimeter, you have to put 3 and 9 in the circles. So the only digits we don't know about in terms of the circles are 4s, 5s and 6s, which have to take up the strain. Right. I have a horrible, horrible, horrible feeling that that was the easy bit of this puzzle. As Maverick flies past my window, taunting me. The reason I'm worried about this is that what I want to do now is to do this logic again in the columns. But the reason I'm not looking forward to this, frankly, is that this arrow here, well, it works for 9s. The logic's going to work for 9s, but it's not going to work for 1s. Because I don't, I can't say that a 1 can't be on this little domino. I don't know. Also, of course, I've been talking about the fluidity of the rows. I'm now going to be having to deal with fluid columns as well. Makes me want to cry. Say to Math, you are a new breed of evil, my friend. Oh my goodness me. Right, let's try it. I think I'm going to try it with 9s and see if I can get my head around what it means for the columns. So, in this example, but we're prepared to be fluid about the columns, we know at this point in the solve we have consumed the 9 in the circle. So, in column 2 and column 8, because we can't put 9 on the arrow, because the arrow circle can't be 10 or higher, it is absolutely true to say those squares would have to be our red 9s. So there is an X-wing on 9s in columns 2 and 8 of the puzzle. Ah, no, that's not true. That's not true. There is an X-wing on 9s, but it might not be in column 2 and 8. So what I can't do is use it to eliminate a 9 from this cell, because it's absolutely possible, for example, this square is a 9, and then the red cells would move to these 4 cells. So I can't use the 9 X-wing in the normal, or in a way that I would be tempted to use it otherwise. So, in these columns, wherever they are, the issue will then be what do you do with 8? Because what you can't do once you've got a 9 in the perimeter is to hide 8 on a between line. But you still absolutely have the ability to put 8 either in the perimeter or in a circle. Although you could only put the 8 in one circle. So you've got 2 perimeter 9s. So although you can deal with the 8 in one column by putting it into a circle, you can't then deal with it in the other. An 8 can't go on the arrow. So in the other column, where you then can't put an 8 in a circle, do you have to put 8 into the perimeter? Or am I misunderstanding this? And is there anything wrong with having 8 and 9 in the perimeters twice? Oh, good grief. I'm not even prepared to apologise for being slow today. I'm not sure I am being slow. I just think this is really complicated. So if I've got to put 8, I have got to put an 8 into the 2 columns that have 9s in the perimeter. Both of those columns do require an 8. And I can only put one 8 into a circle. So don't I have to put an 8-9 pair into the perimeter of either column 2, column 5 or column 8? I think I do. That feels like it's true. And if that's an 8-9 pair, then the hard digit becomes 7 in the column. And 7 and 1 become the hard digits. Hang on, 7 and 1 become the hard digits. I think I'm going mad here, because I can't have 7 and 1 in the same column of the circles, because 1 and 7 are in the same rows of the circles. Ah! I'm so sorry if this is clear to some of you. It's really not very clear to me. Haven't I just proved the puzzle's broken? Or have I gone mad? Hang on, I'm going to do this again, sorry. I have to put an 8. There are definitely 2 columns of this puzzle that have 9s in an X-wing arrangement. This is one possible demonstration of that we've got here. Now, I have to put 2 8s into these. I've got to put an 8 into this column, and I've got to put an 8 into this column. And my choices about how to do that are either I can create 8, 9, I can put the 8s in the perimeters, or I can put exactly 1 8 into these 6 cells. I can't put 8 on the arrow. In fact, so this is always not an 8, but obviously these columns could shuffle round. So I could put 8 once into one of the 6 cells. So in the other instance of that, the 8's going to have, because the 8 can't be bounded by a 9, because we know that the 9 is in the perimeter, in the other instance, there is going to have to be an 8-9 pair in the perimeter. So there is at least one 8-9 pair in the perimeter, but that's broken the puzzle, hasn't it? Because if I put an 8-9 pair here, now in this column, I've got to deal with 7, and I've got to deal with 1. And that's fine. I can deal with those digits. I can put 7 into a circle, and I can put 1 into a circle, but that implies that 1 and 7 in this column are vertical. Whereas the row logic we did implies that the 1 and 7 are horizontal, and they can't, those two things cannot coexist. Oh, yeah, no. Right, unless... Oh, good grief, right. Forget this. I think this is wrong. I don't think you can put the 8 and the 9 vertical in column 2. But what's to stop me putting the 8 and 9? It can't be there. I'd have the same problem. I'd put 1 and 7 in circles vertically, which breaks the logic of row 5. But what would happen if you put 8, 9 vertically in column 8? If you put 8, 9 vertically in column 8, now I don't have the same issue because I can hide the 1 on the arrow, and then it won't break the logic of the row that has the 8, 9 and the 1, 7s in the circles. Maybe. So I put, if the 8, 9 are vertical, I can hide the 7 in a circle without breaking the logic of row 5, which might of course be row 2 or row 8, we don't know. The 7 is fine. The 1 could not also be vertical, but the 1 can live on. So I think it is true to say that we have forced there to be a 1 on this arrow. Because otherwise there is a problem with how the 8s have got to exist in the puzzle. I think that that is true. Just pausing because there is... I wouldn't be astonished if there's a logical hole that I've not spotted there, because that is quite complicated. I don't think I mixed up anything. I'm allowed to flip the rows. I didn't use I didn't assume anything about the precise positions of the 8, 9s in the rows. I just noted that wherever the 8s and 9s do appear in the perimeters, there must be 1s and 7s in the circles, and that is true. Now, the other thing I did was I assumed the 9 logic is good. There's definitely 2 9s in the perimeters. And then you do have to ask the question about the 8s in those columns. And you definitely cannot put 8s in the circles. Sorry, you definitely can't put more than 1 8 in a circle. Yeah, I think it's right. I think it's right. So, now I've limited that square. So this square has come down to being 6 or 7. Now this is going to get even worse, I'm afraid, because this column's pencil marks, that 6 or 7 is a true pencil mark. That is not dependent on all of this column and row shuffling, because we have proved indubitably that there must be an 8-9 pair in the perimeter of this particular column in order to allow the 1 to escape, and the 1 can only escape onto the arrow. So this arrow now, so this is going to get horrific. I really want to use a pen and paper, to be honest, because I'm going to have to remember. See, this 1, 2 here could be wrong. We don't, well, it's here somewhere. It could be there or it could be there. 1, 2 goes with 3 and 9. 8, 9 go with 1 and 7. I think I will remember that because I noticed it for the column logic. 1, 9 go with 2 and 8. These squares here now have to either be 1, 2, 3 or 1, 2, 4. So they definitely have a 1 and a 2 on them, and we know this one is not a 1. I'm not going to delete that 7 pencil mark yet because I might need to remember it. I know that this square is not a 7 though. So this is a between line. And then it's going to have to go up, isn't it, to get to this one. So it can't stay low. So what's the lowest value of this digit? If this is a 5, no, okay, this is not a 5. The reason this is not a 5 is that now these 5 digits would have to be selected from the digits 1, 2, 3 and 4, and that's not possible. So this is not 5. 6 would work. We could have a quintuple. Right, so there's a 6, 7 pair in the column. Again, I'm going to leave this 2, 8 pencil mark in just to remind me, and there must be a 5 in this domino. Now 6 and 7 have been used up in the disjoint subset centres. And right, and that can't be a 4, because if that's a 4, you've got to go 5, 6, 7, and that square's got no fill. So this square here is 3 or 2. With a 1 above it. Now, one of these is a 7, and 7 was one of the digits that I restricted in the rows, wasn't it? 7 went with 1, so whichever one of these is a 7. So this 1 is wrong, definitely wrong. So this sort of the thing we did at the start to explain how we were thinking about the rows was, well, it would have been very lucky if it was correct, but it's definitely not correct, because one of these is a 7, and that we know that in the rows the 7 lives with the 1 and is surrounded by an 8 and a 9. So one of these 2 rows here has an 8 and a 9 around it. Now the 6, unfortunately, we don't know anything about, so we can't take that logic any further. The 2 and the 3. The 2 goes with an 8, surrounded by a 1, 9. So is there any problem with those two being 1, 9? This being a 2 with an 8 in one of these squares. This is so complicated, I cannot tell you. Oh dear, dear, dear. How long have I had? 39 minutes. Oh god, that feels like 5 minutes. That's amazing. That is amazing. That is a testament to how interesting this puzzle is, because I just feel I've been lost in it. Oh, good grief. Right, so I was thinking about 2. The other digit is 3, isn't it? Because 3... What did 3 go with? 3 went with 9, with a 1, 2 surrounding it. Remember, this digit is not real, so I can't use that to eliminate a 1, 2 pair in this row. 3 would go with 9 in one of these two. I know that this is an 8, 9 pair. I know there is another 9 in one of these 4 positions. I think I've got to get rid of... I'm going to get rid of those ones. I'm going to put ones like that, just to try and remind me about the... That's got to be a 3 as well. And I've got 2 8. I've got 2 8s in the 1 9 rows. I've got 1 7s in the 8 9 rows, and I've got 3 9s in the 1 2 rows. And okay. So what do we know now? I don't know whether to revisit. Do we have to revisit the column logic now? We know there's an 8 9 here. I know there's definitely not an 8 9 there, because that's going to break this column, because that's going to force 1 and 7 vertical. So there's not an 8 9 there. Is there another 8 in the perimeter? I suppose that might be a sensible question. So we've got 3 columns here. So we've got to put 3 8s in. We can only put 1 8 in a circle, and we know it's not here. So there is 1 8 in a circle over here. Ah, no. Look, if I put the 9 back, you'll see what I mean. I can hide an 8 vertically underneath the 9. On the between line with the 9 on it, you can put an 8 beneath it. So you don't actually know. So it's not true. It's not true to say there's another 8 in those 4 squares. There might be, but there doesn't have to be, because wherever the 9 lives, it can shield an 8 on its between line. Bobbins. So maybe we've got to think about 1 instead then. So 1 is definitely not in those 3 cells. 1 is going to be on a... Yeah, that's interesting. So there is definitely a 1 in the perimeter. There is definitely a 1 in the perimeter, because let's count again. Look at these 3 columns. We know there are 3 1s in these 3 columns if we complete the puzzle correctly. That is the idea. Well, there's a 1 here. That's 1 1. There's a 1 in a between line. That's a second 1. And now the third one will have to be in one of those squares. Now, what does that mean? There is definitely a 1 in one of those squares. That means right, here we go. Here we go. is that 1 in the same, is that 1 paired up with the 9? That's the question we can ask. The answer to that, I think, is no. And the reason for that is that if we pair the 1 with the 9 in a column, the circles in that column must contain 2 and 8, because those are the digits that cannot be shielded. But if we put 2 and 8 in 2 of those 3 squares in the columns, we now can't put 2 and 8 horizontally in the row that has the 1 and the 9 in its perimeter. So that is not a 1-9 pair. And there is a 1 segregated away from the 9. And still, we do not know whether the 1s are in column 5 or in column 2. And we do not know whether the 9s are in column 2 or column 5. But we know that we must keep them apart and play gooseberry with them. And that means that so in this column now, in this column where we've got the 1s, we've got a 9 somewhere in one of those 3 squares, haven't we? Because we need to put a 9 in a circle. And the 9 is not in those 3 squares. So there is a 9 in one of, let's just put it back in here just to say, so we can analyse it. So we've now got a 1 in one of those squares. Okay. Do we know what digit accompanies the 1? That's the next question. And the answer is a bit... I don't know. Ah, good grief. Good grief. I think I've got it. I think I've got it. How about this? How about this? In the column that has the 9 in it now, let's come back to this. This column we know is not bounded by 1 and 9. So we know that the 1 in this column is definitely in one of those cells. The 1 is definitely in one of those cells. Okay, that's not quite what I was trying to do, to be honest. What I was trying to do... Oh, my phone's going again. Hang on. I'm wondering whether I actually have to take that. I'll just give it a moment. Because I want to just finish my train of thought. If there is... in this column, we know there's a 1 in the perimeter. And we have to deal with the other digits in the perimeter. We don't know what that digit is. But I really want to have... What I'm trying to do is I'm wondering whether I can prove that the 2, which is currently an option for this cell, has to live in a circle in a different column. That's what I'm trying to prove. And I'm not being very clever about that, I'm afraid. Let me think about this. So in this column, the 1 has become problematic. And if the 2 is not in the perimeter, it is absolutely true to say the 2 must be in a circle. But why can't you have a 1-2 pair like that? Why would that be difficult? That in fact would force 3 into one of those squares, and that would force this to then be a 2. So that's what I'm wrestling with. Which is tricky indeed. My phone is still buzzing at me. It's terrifying. Let me think about this. So, if you put what you can't do is put 2 and 8 in the perimeter here. So there must be a 2 or an 8 in a circle here. That's true. And there's of course 2 and 8 in the circles in that orientation. I feel like there's something here. I'm just not quite seeing it. Let's carry on thinking about it. How can we get a grip on this? How can we get a grip on this? A 9. Maybe I do it that way instead. Rather than, yes. Right. We'll do an either or. If this is a 1-2 pair, then it looks okay at first blush, and I thought it was okay, but I was forgetting this row, which is a problem, because you can't, I now need to put a 3 in one of those squares, one of these 2 squares, but I simultaneously need to put a 3 in one of those 2 squares. That's not possible. So this is not a 1-2 pair. It's something else. And whatever else it is, I now have to deal with putting 2 in this column. And the only place 2 can go in the column is in one of those squares. So, it's not here. It's not here. That's not possible. It's not possible. Good grief. I think that logic is right, isn't it? You've firstly got to figure out, let's just double check. This is not going to, I'm sure it's not going to depend on whether the 1 is here and here or here and here. Because wherever the 1 goes, we then have to ask the question, what digit accompanies it in the perimeter? Knowing we can't accompany it with a 2, because if we do that, we've got the problem of vertical circles versus horizontal circles, because we know that one of the rows does contain a 3-9 in the circles, so this column couldn't. Once you rule out 1, 2, you've got to put another digit other than 2 in here, and it doesn't matter what that digit is. You've then got to put 2 in the column in the circle, because you know that there is already a 9 in one of these cells, and we know that there's a 9 in the column that has the 1s in the perimeter, because we know that there are 2 9s in the perimeter, and those 9s are elsewhere, and we can't accompany them with a 1. This is torturous, I accept it, but I think it is true. So, I think, and I don't know, this is so weird, because I don't know where the 2 goes. I just know it's not there, because there is a column that has a 1 in the perimeter. So that's a 3, I think. Which means that's not got 4 in it. So now we know things. Now we get... Yes, this is the first digit in the grid, is a 3 in this position. This is now a 6, and this is a 7. And now we can get rid of some pencil marks here. So this has become a 4-5 pair. And now if we've got a 7 here, don't we know what row this is in terms of... Yes, we do. Look at this row. The 7 was in a row with a 1 in a circle, so there is now definitely a 1 in one of those two squares, surrounded on each side by 8s and 9s. This is where it's going to get tricky. I'm going to shift those to there to remind me that that's... So these 8s and 9s are now correct. There is definitely a 1 in one of those two squares. Now the 3, that had a home with a 9 surrounded by a 1 and a 2. So this, oh, hang on. Yes, okay. So now actually if we shuffle these round, we can now see exactly how these rows are disposed, can't we? Because this one, which was a 1-9 pair framing a 2-8, now can only live in row 2. And that's because once we know there's a 3 in row 5, we know the 3 is joined to a 9 in one of these two digits, surrounded on either side by the 1 and the 2. So this row actually needed to shift down to this row needed to shift down to this row, and the bottom row, the bottom 8, needs to shift up to that row. And we need to do all these things now without messing up. So this becomes, I don't want to get this wrong. This becomes a 1-2 pair with a 3-9, well, with a 9 in one of those two squares. So we can get rid of the 1-7s there. This one at the top becomes a 1-9 pair with a 2, with a 2-8 into these squares. Yes, it's just a 2-8 pair into these squares, and that can't be an 8 because I can't double 7 the between line. So that's a 2, that's an 8, I think. So let's double check this now. So now we've got, we can remove the 2 and the 8s from there. They've shifted up to the top. We've definitely got a 1 in one of these. We don't know about these 1s and 9s. These could be in the wrong order. It's probably, oh well, yeah, they could be in the wrong order. In fact, that is not a 9. Because it's next to an 8 on a between line. So we know there's a 9 in one of those two positions. It's definitely not there. So that is a 9. And that implies our 1s. So this is the first thing we've got right. Our 1s were correct in column 5. And that means that's not a 1, which means this is a 1. And the 9s were correct in column 2. So we had to shift all the rows around, but we didn't have to do as much jiggery-pokery with column 2 and column 5. And now, look, those squares, look, have got to be, they've got to be 4 and 5, and that can't be 5, it's too close to 7. So that's 4, and that's 5. And let's get rid of the pencil marks here and here. Now what do we do? I suppose what we can do, I can do that. That's a 2-3 pair, look. I can do that. That's a 5-6 pair. That's the only digits between 4 and 7. And a black Kropke dot cannot have a 5 because you can't put 10 or 2.5 on it. So that's 6, that's 3, that's 5, that's 4, that's 5. That's 2, that's 3. It's using the 3 here. 3's got to go in one of those cells by Sudoku. This is going to be way, way over an hour if I get through this. Now, what do we do next? Don't really like these 9s in the center of these cells. I think I'm going to get rid of those now and put them in the corners. Do the same with these 1s. Put them in the corners. Now, okay. What What else have we learned here? Can we... These are relatively close together. They've got to be 2, 3 or 4. That can't be... is that just a naked single? I think it is. It sees 3, it sees 4. So that's got to be a 2, I think. So this is a 3 or a 4. Oh goodness, the other thing I've got to try and remember here is the disjoint sets, isn't it? Because I've totally been overlooking that for a bit. Those squares have got to be 6 and 7. Let's check the disjoint. Now checking the disjoint sets for that one. And this column, which we've got quite a lot of known stuff in, this square at the bottom is a 4 or a 9. And this square at the top is that's a 3 or a 9. I don't think that can be a 4 because of that one. Have we got anything else disjoint going on that's seeing any of these cells, either that one or that one? Oh, yes, that 2 is seeing that square by disjoint. This is horrific. This is so hard. This is so difficult. That's a 9 now. That's a 3. So that's a 4. That's a 9. That's an 8. That's a 9. That's an 8. That's a 9. That actually felt like I was relatively useful there. That's actually given me quite a lot of things. So remember, I've still got to put a 1 on one side of column 5. Let's just double click the 1. Yes, 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 yes. Look, this one is the top middle of its box, so that's not a 1. So that must be a 1. How did you come up with this, Zatamath? It is completely insane. I don't think anyone's going to agree with me. Look, 2s. That's got to be a 2 by Sudoku. That's a 3. I do not think anyone is going to be disagreeing with me when I say this is among the most complicated things I've ever seen in my life. This is a 1 and this is a 6. And yet, you actually invented it. It's mad. 4 and 6, 4 and 6. So we've got a 4, 6 pair in box 7. Those squares are 5 and 7 to complete those. So those squares there are 8 and 9. Well, that's useful actually. 9 and 8 go into the grid. Those squares are 5 and 7. 9 is here by Sudoku. 9s we've actually got quite a few of. Look, nearly all of them, but not quite all of them. I think there's a 9 in one of those and a 9 in one of these. Never put a 9 on a between line. Now, what about that line actually? That's relatively close together. That's 3s, 4s and 5s, isn't it? So that's no 5 here. There's no 3 here. Now we should check the disjoint, and don't think that's seeing anything. Probably wrong. This one is the middle right cell. Don't think that one's seeing anything either. Probably wrong. Okay. Where should we look now? Oh goodness, I thought I made a mistake then. I was looking at this 8 and looking at 9 thinking, you can't put a digit between 8 and 9 there, but I don't have to. I just have to put a digit between 4 and 9 there. 5, 6, 7. That's 5, 6 or 7. No, that's not 5 by Sudoku. That's just 6 or 7. Right, disjoint. Let's check. 6. That's a bit interesting. Look, those two squares are in the same position. So these are different digits, which means that digit... Hang on a sec. Let's actually, I'm tempted to colour this in. Let's just go to colours. I think we now understand all of that logic at the beginning. Now this cell and this cell are different because they are in the same position of their disjoint sets. So let's fill those in different colours. Now that means that square is blue because it's not this one, and that means that square is also blue. I'm scanning the disjoint to see if I can see what it is. It's a 6 or a 7. I don't see how to do that actually. Sorry. Okay, so where should we look now? We shall have a look at maybe the 5/9 line. That's probably the most restricted of those we've got left. That's got to be 6, 7 or 8. And 6 comes out of that one. The middle left of a line, that sees an 8 there. So that's become orange then. Oh, in fact, I've got a 6, 7 pair here, so that becomes an 8 now, which is nice. Oh, this is love. No, it is. It's lovely. It's lovely. 6 and 7 here. 6 and 7 in the, well, the orange 6 and 7 in this box at the top has to be in one of those two squares by Sudoku. And now that means one of those two squares is a 6 or a 7. Well, it's going to be that one because it's the only one that can be. So actually, those two are 6s. These are 7. Whoops. Those are 7s. 7 now is locked into one of two places in box 3. Check the disjoint. No. 6 is locked into the same positions as 9 in this box here, box 6. Those squares there have got to be 4 and 8. Again, let's just double check the disjoint quickly. 4 and 8 don't seem to work. 5 and 7 into the top of column 9. 5, no. 7, I think I already looked at 7s. No. Okay. 6, so that's a 6 orange. So that's not a 6 orange, and 6 orange goes in here. So maybe we focus more on 6s just to try and finish those off if we can. Let's put that one in. Double click them. Have we got anything in the bottom row? No, we don't. Oh well, this one, which is useless. Ah, you rotten thing. What about in... No, okay. Rats, foiled again. I don't know where to look. What about this digit? That's a sensible place to look, isn't it? Because that's the last digit in its row. And that actually is helpful, believe it or not. That's very helpful. 5 and 7 go into the grid. That's, oh look, this 7 sees that square by disjoint. So the 5 and 7 reverse up here. Oh yeah, this is actually gorgeous because that 7 now sees that square by disjoint. So that all gets fixed as well. 7 is in one of those two cells. We might be able to do something about that. And 5 is here exactly. So we've done very, very many 5s in the grid. I think we've only got 1 left to place. Imagine if I've made a mistake in this puzzle. I will be sick as a parrot. Okay, so this row needs 3s, 4s and 7s, doesn't it? So this is either 3, 4 or 7. This is either 4 or 7. I'm looking, I am, oh yeah, 4. 4 sees that one. They are in the same position, so that's 7. So this is not 7. Oh, whoopsie. This is not 7. What about the disjoint for these? No, okay. I don't see anything that's going to overlap. Might be mis-scanning, but I'm not seeing it. What about these squares then? 1s, 2s and 4s. I can see we can certainly get rid of... Oh, we can just place 2. That's just given. And that means we place 1, and that means we place 4. And that gives us the 4 and the 6. These two squares now are 2 and 3. This 2 sees that square by madness. So that's a 2 and a 3. That's a 2 by Sudoku. This box needs 1s, 3s and 8s. 3, look, can only go there. So this is a 1-8 pair, there's a 1 here. So that's 1, that's 8, that's 8, that's 4. Ooh, don't like the look of this at all. I've got a 6-9 pair here. The disjoint is going to have to deal with this deadly pattern. or I'm going to cry. Yes, the 9 here sees that square. Good grief. So that's a 6, that's a 9, that's a 9, that's a 6. Now, have we resolved these 3s and 4s? Yes, that 3 is doing it. 4 and 3 go in there. Delete that. Maverick's taken off in his helicopter now by the sounds of it. This is a 4-8 pair, which we can just write in. This square's got to be an 8. That square's got to be a 1. It does look like... I'm not saying anything, actually. 3, 7. 3, 7. Yes! Oh, I'm quite proud of that. That was so difficult, I cannot tell you. 1 hour, 10 minutes. I hope it's correct. That is going to be hard for me to check. I'll check once I've stopped the video, because I can't check all the disjoints. The software won't do it. So I hope it's correct. What a puzzle that is. That is ridiculous, Satomath. Absolutely ridiculous. It's one of the most complicated things I've ever tried to solve, frankly. I really liked the start because I could do it and understand it. But then the column stuff after that it scrambled my brain, frankly. So you've definitely made a mockery of me there. You even stopped me speaking, clearly. The fact that everything could switch round, and this evil, evil, evil arrow in which could hide low digits on it, that made it, it made it perplexing to try and get my head around it. But I think I did. And for that I'm relatively proud. So another movie length or almost movie length edition of Cracking the Cryptic, and another totally genius puzzle by one of these incredible setters that we have the privilege of showcasing on the channel. If that's not worth a subscription, I don't know what is. Thanks so much for watching, and we'll be back later with another edition of Cracking the Cryptic.